intensity of a light source, and that's my rendition of a flashlight, okay? I know it doesn't look like a flashlight, but bear with me, okay? So some of you know that, especially if you're a hiker or, you do something at night, they have these halogen headlamps. If you're a skier and you do something at night, as opposed to little regular incandescent light bulbs, which are different than those halogen light bulbs. So intensity of a light source is measured in candela, which is abbreviated CD, or candle power. And it goes back to the old days of the whales, when people lit lights and candles with whale oil, okay? So intensity of a light source is measured in candela. And illuminance, so this is what I'm measuring over here. This is the intensity of the light source. And illuminance is the light energy per unit area. So it's what you are seeing per unit area. Okay, everybody, does that make sense to everybody? And illuminance is directly related to the light intensity. Does that make sense? So the amount that you are going to see, the illuminance is directly related to this. Okay? Is everybody good with that?
Does this say candela?
Yes. Candela. C-A-N-D-E-L-A.
Light energy for what area?
Per unit area. Illuminance is the light energy per unit area. Here's my little button for my battery, for my flashlight. We ready to move on?
Wait. Does that say light energy per unit area?
Yep. So I'm going to move this up a little bit. So does it make, all right, so we just talked about illuminance is directly related to the light intensity. So we have direct variation. And so what we're going to be doing is just translating what is dependent on what. So what is illuminance is directly related. So I'm going to actually shift this up a little bit. And the word problems that we're going to do is they're giving us variables. They're just going to say, let I be intensity and E is illumination. So what is dependent on what?
The light intensity is dependent on the distance?
Okay, well we just said back here, illuminance is directly related to the light intensity. This illuminance is directly related to the light intensity. And if I'm telling you that this is my illuminance, and I'm telling you that this is my E, and it's directly related to the intensity, which is my I, can I write the equation, and I know that this is direct variation, can I just plug in these letters into that equation?
Yes.
Yes. So this is directly related to the intensity. Okay? I don't know what. So my E is directly related to my I. Does that language make sense to you? Okay? And that's all these problems are. It's really just understanding what is dependent on what. And if it's direct variation, we know that if I were to graph this, I would say that the illuminance, which they're saying is E, is dependent on this, This is always my what? Axis. My y, and this is my x. And the word problems are just about thinking about that. What is dependent on what? How would I graph that? That would be on the y-axis, and so I would know which is related to which. Okay? All right. So far, so good? All right. So, let me see. Where am I? All right, I'm going to read this to you. So, at a distance of 12 feet, and this is what I've illustrated for you, at a distance of 12 feet from a 60 CD light source, a photographer's light meter registers an illuminance of 18 units. Find the constant. So these are really just plug and chug type problems. You just need to be able to just read and understand what is dependent on what. Okay? So, let me see. Why don't you try? Let's try the one on the bottom. And this is right here. Okay? So a light meter is the same distance from two light sources. This is the try it on the bottom of the page, page 460. Okay? When the first source of a 90 CD lamp is turned on, the light meter reads 7.2 units of luminance. Okay, so what is dependent on what? The illuminance is dependent on the intensity, and the intensity is measured in CD. Okay, so do we know what the constant is? No. Okay, can we solve for the constant?
Yes.
Okay, so could you write an equation right now so that you have that information in front of you? Y equals what?
The 7.2. No, but y would be, don't we have a number for y?
What is Y? What is dependent on what? Illuminance is dependent on intensity. Do we know what the illuminance is? The light meter reads 7.2 units of illuminance. Do we know what the illuminance are? Yes, no, maybe?
Yes.
Yes, okay. So I know that the illuminance is dependent, illuminance I think was E, isn't that our E? E is dependent on our K, or our intensity times our K, correct? Okay, so our illuminance is what? 7.2 is equal to, when the first
But that would,
source,
K times
but that'd be
9.
90K.
what?
90K.
90K,
That's, it's gonna be a decimal.
okay? So can I figure out what my constant is?
Yes.
What?
I?
No, 7.2 divided by 90.
7.2 divided by 90? I want K by itself. What am I doing?
0.08.
So K is equal to 0.08. Okay, the constant is very small. Okay, let's read the second part of this. When the 90 CD lamp is turned off and the second light is turned on, the light meter reads 6 units. Find the intensity. So what do we have again? We have the same thing. Do we know what the constant is?
Yeah,
What?
0.08.
Okay, do we know what? Find the intensity.
So T is 6.
So the light meter reads 6, and the intensity is I. We don't know what it is. Can we solve for I? Yes, yes. And what would I be?
75.
75.
Okay. so 75 is equal to I. So these word problems are just a matter of understanding what the language is and what is dependent on what. Okay? All right. All right, good. Good, good. So we've done that. You guys are great. All right. These next sections are on current and electricity. And we're going to read one of these. Okay, now let's look at this. The current I of an electrical conductor. All right, so what is an electrical conductor, by the way?
Metal.
Okay, so something that conducts electricity. The current I in an electrical current varies inversely with the resistance R of the conductor. What is the resistance? It is what resists, so that, I mean, think about if you have a toaster oven or as a toaster or something, what happens to those cords? The cord. They get why?
Because there's electricity out there.
Because there's how much?
A lot.
There's a lot, okay? And so, Stephen, what were we gonna say?
They get hot because there's resistance so that the electrons can't go through and they start to move faster.
Okay, that's right. So there is resistance. Okay, so in this case, the current in an electrical conductor varies inversely. Do we have an idea of what our equation is going to look like?
Yeah.
What?
I
K
equals
over X.
Yeah.
K over X, okay, because it varies inversely with the resistance R. So what is I? Is I your Y
Why is
or,
your current?
pardon me?
It's 130.
Okay, the current, I know, but is that our, we're gonna write this in terms of I. The current in an electrical conductor varies inversely with the resistance of the conductor. So how are we going to set that up?
the current depends on the resistance, so the current would be your X.
My current is my
I.
X.
This is your I.
No, my current is my Y is my I.
Oh, yeah.
This is K over my R. I don't know what the constant is. The current, my I, is, the current is, so I could write that as 1/3 is equal to K over what?
R.
When the resistance, and that is 360. How do I get rid of 360? Multiply it by 360. And 1/3 of 360 is
120.
120 is my constant. Okay, and